All right, here we go. Quarter 3, week 8, day 2. Find the quotient. We are dividing. They love to give us that one because we can keep, change, flip. We have the 3/5. We change this the division sign to a multiplication sign, and we do the multiplicative inverse or the reciprocal of 7 over 8 and make it 8 over 7. All right, 3 times 8 is 24. 7 times 5 is 35. 24 over 35. Can we simplify that? Is there any number that goes into both 24 and 35? Nope. So there's our answer. 24 over 35 is the answer to this division problem. What is 38% of 94? Remember, guys, 38% is 38 over 100. And then if you do 38 divided by 100, it's 0.38. So remember, this and this and this is the exact same amount. So if it benefits us to keep it a percent, we'll do it. If it benefits us to make it into a fraction, we'll do that. If it benefits us to change it into a decimal, we'll do that. All right, so if we want to find out 38% of 94, that just means we're multiplying. So we can have two different options. We can do 38 over 100 times 94 over 1. We could do it that way. Or we can do 0.38 times 94. Both of these is going to give us the exact same answer. So I'm not sure why I did that last one. All right, so let's just do 0.38 times 94, and that's going to give us 35.72. So that's our answer for that one, and that's all we have to do. We could have actually done the 38 times 94, and that gives us 3,572. And then we do 1 times 100, which is 100. Okay, and what will we do in that situation? Well, we divide 100 into it, which ends up making you move the decimal 2 places to the left, which would end up giving us our exact same answer, 35.72. So whatever works best for you, use that method, but there's our answer. All right, let's evaluate the expression. We're going to use PEMDAS parentheses, exponents, multiplication, division. This is the order that we're doing it in, addition, and subtraction. All right, so are there any parentheses? Yes, there is. There is a 32 divided by 8. So let's rewrite it, 4.5. And then in parentheses is going to be 32 divided by 8. Well, how many times does 8 go into 32? The answer is 4 times. All right, so we've done in the parentheses plus 12. So we have 4.5 times 4 plus 12. So what do we do first? 4.5 times 4, or do we do the 4 plus 12? Well, we're following order of operations. Multiplication and division comes before addition and subtraction. So it's going to be this one, 4.5, okay, 4.5 times 4. And if we do that, that is 18. So we have 18 plus 12 left. So all we have to do is add those. So 8 and 2 is 10. And 1 and 1 plus 1 more is 3. There we are. Our answer is 30. Okay, so that's all there is to evaluate that expression. Solve for n. Okay, so this is a one-step equation because it only takes one step to solve this. We do have a 14 and an n right next to each other. That means that's multiplication. To solve for this, we're going to do the opposite operation of multiplication. The opposite of multiplication is division. All right, so to solve for this, we're going to divide both sides. And, of course, to get n by itself, we're just going to have to divide 14 by itself. 14 goes into 14 one time, so technically there's just one n left on this side. So I'm not going to put a 1 in front of the n because that's just one n. There it is. So at this point, we take 252 divided by 14, and that's going to give us 18. So n equals 18. And you can double check that by doing 14 times 18. And if you do that, it ends up being 252. So to solve for n, divide both sides by 14. Okay, we need to find the area, and this shape is a trapezoid because it has two parallel lines and then two lines that are not parallel, because if they continued up this way, they would eventually intersect, right? So there's two different ways we can do this. There's a formula for the area of a trapezoid, which is base 1 plus base 2 times the height divided by 2. So this would, I guess it's time to start the class. So we have base 1 plus base 2, and then we're going to multiply that by the height and divide it by 2. Or we could find the area of two triangles. We could find this triangle and this triangle, and then find the area of this rectangle, and then add those three things up. Okay, so let's just quickly do the triangle, triangle, and rectangle. Okay, so the rectangle is going to be 8 by 7. So what is 8 times 7, or 7 times 8 is 56. So that's 56 feet squared. All right, so the whole distance from here to here is 14. So this whole distance all the way across is 14. But this is 8, right? And so 14 minus 8 is 6. So which means if we divided this up, there would be 3 on this side and 3 on this side. So 8 plus this 3 would equal 14. So we know that the base of each one of those triangles is 3. We know that the height is 7. So 7 times 3 is 21. But remember, they're triangles, so we have to divide those by 2. So each triangle is going to be 10.5 feet squared. Okay, so that's on each side. Now, since it's on both sides, we could have just said, you know what? 10.5 and 10.5 is 21. So let's just use 21. So let's just do that. We'll do 56 plus 21. So if we add those two together, our total is 77. So the area here would be 77 feet squared. Now, if we used the other method, okay, the base 1 plus base 2 times height divided by 2, let's see if we get 77 feet squared as well. Okay, so these are the two bases, and it doesn't really matter which one we call base 1 or base 2. So, and here's our equation. So let's just do 14 plus 8. And then what is the height? Well, the height was 7 times the height divided by 2. Okay, so let's do this. 14 plus 8 equals 22. So then we're going to do 22 times 7, and that's going to equal 154. But we're going to then divide that by 2. 154 divided by 2 equals 77. Okay, so we could have done it via a formula as well. So either one of those would have worked out just fine. All right, sometime I'll show you exactly why that formula works, but for now we'll just leave it at that. So the answer is 77 feet squared. All right, so we're going to find the surface area. We have a base, okay, which I drew right over here. And then we have these triangles that can fold down, which I kind of drew over here. They're not all perfect. They're all supposed to be the same. And then I ran a little space there. But anyway, all right, so let's find the surface area, which means we just have to find the area of each one of these shapes. Well, to find the base, it's length times width. So 6 times 6 is 36. All right, done with that. So now all of the triangles are the same. We have a 6 as a base. We have a 9 as the height. Okay, so 6 times 9 is 54. But they're all triangles, so divide them by 2. So each triangle is 27 centimeters squared. Okay, it's a weird 27, but there it is. Okay, so then all we have to do is realize, well, there's 1, 2, 3, 4 triangles, so just do 27 times 4, and that gives us 108. So far we have 108 centimeters squared, but then we still have to add on this 36, and that's going to give us 144. So, our answer is 144 centimeters. Is it squared? Is it cubed? Just regular centimeters. We're finding area, so it is centimeters squared. All right, there's the answer for the surface area of that square pyramid. Okay, we're going to try to make this the most efficient, quick lesson possible. We are looking at box and whisker plots. Okay, the reason why they're called that is because they have boxes and they have whiskers, kind of like cats have whiskers. Okay, so that's just what they're called. There's 5 different things you need. If you have a set of data, you need to have the highest number in the set of data. Okay, so these are 2 different box and whisker plots. So this one here is showing the highest data of one of the data sets, and this is showing the highest data of another one. Okay, so you need the highest number. You also need the highest score, or the most people, or whatever it is. Then you also need the lowest number. So those are going to be the end of the whiskers. The highest number is at the right. The lowest number is at the left. Okay, and then you have to find the median, or the middle number of each data set. That might be lined up like this, or it might not be. Okay, but it's the middle number of the data set. And then you have to find the middle number of the bottom half of the numbers. So you cut the data set in half. Ignore the top half and just look at the bottom half of the numbers. Find the middle number in the bottom half. That would be this number here that you would plot. And then you would find the middle number in the top half of the data. That one will be that. So you need the highest number, the lowest number, the median, and then the middle of the top half of the numbers and the middle of the bottom half of the numbers. Those are the things that you need to make a box and whisker plot. Okay, I know that was a flood of information, so let's go ahead and work through it. Okay, there are a few questions being asked here, so let's go ahead and do it. It says, what is the difference in the interquartile ranges of test 1 and test 2? All right, so here's test 1. Okay, you can see that this one is above the 10 and this one is above the 17. So 17 to 10, well, is a difference of 7, right? So the interquartile range is 7 for that one. And then here is 17, and this is 7. So the interquartile range for this one is 10, okay? So basically, these are 10 apart from each other. And it's asking what the difference is. Well, we just do 10 minus 7. So the answer is 3. So the answer to this part is 3. And it says, what was the median for both tests? Well, I showed you that it's not always the case, but in this situation, it was really nice that the median was the same for both sets of numbers. Well, here's 12, here's 14, so what's right between 12 and 14 is 13. So obviously the median in both of these had to be the 13. Now the last thing they want us to do is draw a box and whisker plot for the following set of data. Well, one thing I notice is that this data is not in order from least to greatest. So I'm not going to be able to find the median until I do that. So let's do that first, and then we'll make our box and whisker plot. Okay, we talked earlier, what we need for a box and whisker plot is the highest and lowest number, which we have right here. It has the highest number and the lowest number. Then we need to find the number in the middle. Well, it just turns out that this has a shared middle, which is 18 and 23. So we had to add those up, divided by 2, so this is our median. Then we have to find the middle of the lower half of numbers. There's 4 numbers here. There's 4 numbers here. So we have a shared middle again in each of these situations. So we have the lower quartile of 11.5, because that's the average of 10 and 13, and the upper quartile of 25.5, because that's the average of 25 and 26. Now we have everything to make the box and whisker plot. Okay, so I made my number line, and we went ahead and plotted everything up here. And to make the box and whisker plot, we simply connect the 2 quartiles with the median in the middle. And then to make the whiskers, we make a line from the box to the highest number and the lowest number. And there we go. There is our box and whisker plot. That's how you make them.